question number 9 and 13. So I'll just put that up on the board, and you can go through those questions, all of you first, then we'll discuss about them. So vectors module exercises doubts. We'll start with exercise 1. So far the questions I've received are 9, 13 and 21. So let's start with question number 9. Just go through it, all of you first, we'll discuss. So just go through question 9 and 13, all of you will discuss quickly. Okay, so question 9 has given you two vectors, A and B. Okay, so these two are given to us. Okay, and now it is asking for a vector C perpendicular to both A and B. It says that C is perpendicular to both A and B. Okay, and magnitude of C is 3 units. So from that, so A and B are given. Okay, and from that we have to find the vector C. Okay. So I'll tell you the general method first, then we'll discuss this particular question, because this is actually a very easy question the way it is given. So in general, when we have a question like this, you know that A cross B is equal to AB sine theta n cap, where n cap is the unit vector perpendicular to A and B both. Okay. So n cap can be just expressed as A cross B divided by its own magnitude. So in this case now, C's magnitude is 3 and C is perpendicular to both this. So that would mean that the vector C would be plus minus 3 n cap, like this. Because it could be in either direction and n cap is this. Okay. So this is the general method. However, in the question that is given, it's very easy because you don't have to go to the cross product thing. You can understand very easily that because E is given as I cap plus J cap and B is given as I cap minus J cap. So here you don't have to do this much. Here you can just use this, that since A and B lie in the xy plane, okay, so therefore here C must be perpendicular to xy plane. So that means C must be along either plus or minus k cap. So it's very easy. So therefore the vector C is either plus or minus 3 k cap. So you can get away without calculating any cross product and all that. You can do this question very simply by just doing this calculation here. But in general, if they had all three components, then you should have used this method. You should have used this cross product method. Okay. But here we can just use, since they lie in a xy plane, so you can directly solve without calculating the cross product. Okay, we'll discuss the seventh question also. So ninth is done. Now next, let's come to the seventh question after this. So write this down and come to seventh question. Okay, so now seventh question is actually based on the language of sixth question. So we'll have to go through both of them. So let us look at questions 6 and 7 together. So it says that we have three vectors, let's say A, B, and C are of magnitudes 1, 2, and 3 units respectively. Okay, and are along the consecutive sides of an equilateral triangle. Okay, so from that we have to find the magnitude of A plus B plus C. Okay, that is question number 6. Okay, and we have to find the angle of the resultant, which is A plus B plus C, with respect to the vector E. That is the seventh question. Okay. So first of all, let us understand the language of the question itself by drawing a simple figure. So suppose this is some equilateral triangle with interior angles 60 degrees each and some dimensions. Then what does this statement here mean? That they lie along consecutive sides of equilateral triangle. So in this diagram, the vectors A, B, and C will have to be drawn like this. That the vector E is in this direction of magnitude 1, let's say. Vector B is along this direction and of magnitude 2. And the vector C is along this direction, like this. This is the meaning of this statement. So this would be the vector A of magnitude 1. This would be the vector B of magnitude 2. And this would be the vector C of magnitude 3. Because let us say the equilateral triangle is PQR. So suppose we have equilateral triangle PQR. So this statement means that the vector A is along side PQ. B is alongside QR and C is alongside RS. So that's what, sorry, RP. Okay, along the side RP. So this is the meaning of this statement here. Okay. So next what we will do is from this diagram, one way of solving is, method one of solving is use component algebra. Okay. So for that, express A, B, and C in I cap J cap form, and for that take the x-axis along PQ for the triangle. So take your x-axis like this and y-axis like this, and express A, B, and C in component form and do it by component algebra. So if you haven't done this question, you can just quickly try out this method and I'll explain to you exactly how it works. There's also the second method, which is the geometrical approach. We'll discuss about that also. Okay. But first you work it out by this method. So try to express A, B, and C in component form first. I'll put it up on the board. Just write it on paper yourself. See if you can get that correct. Okay, so let's see how this works out. So if you take our coordinate frame as I've advised you to take, like this, okay, so that this is your x-axis, this is your y-axis. So the triangle we had drawn above was like this. The base was parallel to the x-axis, this one. So now in this diagram, how I will place my three vectors a, b, and c. I'll have to place them like this. The vector a will be along the positive x-axis and of magnitude 1. So this is the vector e. So the vector e will be expressed as simply I cap. Okay. On the same diagram, my vector b, notice, will be like this now. It have to be placed like this of magnitude 2, where this angle is 120 degrees, because you can see here that this angle is 120 and A was along this side and B was along this side. And now likewise, when I draw the vector C, in this diagram C will be along this side, its magnitude is 3. You can see that this angle is again 120 degrees. So when I draw the vector C in my xy system, it will be over here. It will be of magnitude 3 units, where this angle will be 120. So this whole angle is 120. That also means that this angle here, this one, this is 60 degrees. So that way we can express the vectors b and c easily now. So the vector b, you can see, is minus I cap plus root 3 j cap. Okay. And the vector c, the same thing, will become minus 3 by 2 I cap minus 3 root 3 by 2 j cap. Okay. Because you can see that the vector b has magnitude of 2 and it is at 120 degrees with respect to x-axis. Similarly, you can see that the vector c has a magnitude of 3, but it is at 240 degrees with respect to x-axis. So this is how we'll write it in component form. Yeah, that's also fine. You can draw it in any way. But we are using component algebra here, so it will make sense to draw it this way. So now you can see that the resultant sum R, so just add these. So you'll see it is minus 3 by 2 I cap, and this will give you minus root 3 by 2 j cap. So the magnitude of the resultant, next step, so the magnitude of the sum, so this becomes the answer to the sixth question. Now the seventh question, the angle between this resultant and the vector E. So you can see the resultant is minus 3 by 2 I cap minus root 3 by 2 j cap, and A was the vector which is nothing but I cap. So cos theta, so when you work that out, you can see it is, so you can see that theta will work out to be 150 degrees, because cos 30 is root 3 by 2. So cos 150 is minus root 3. So this is the first method of solving this. This is the component algebra method. Just make a note of this first. Then we'll see next the geometrical approach of solving. Yes, so hope this is clear to all of you. Now let us see the same problem by the geometrical approach. So when we use the geometrical method for adding these vectors, what we'll see is that to begin with, we had drawn the vectors with respect to this triangle PQR. So we had vectors A, B, and C like this. So they were of magnitude 1, magnitude 2, and magnitude 3 respectively. But also this angle is 120 degrees, and this angle is 120. So when we use geometry to add these vectors, we have to just draw them head to tail. So I'll make a slightly larger diagram than that one, but the idea is the same. So E is a vector of magnitude 1, suppose, so it will be like this. So in comparison, B will be longer, but at 120 degrees. So something like this. Okay. And in comparison, C will be even longer because it's of magnitude 3 units. So let's say C is somewhere here. So these are the vectors drawn head to tail. Where the angle between vectors A and B is 120 degrees, and again the angle between B and C is also 120 degrees. So we have drawn A, B, and C are drawn head to tail to add them. Okay. So the resultant, which is A plus B plus C, in this diagram will be the vector from the origin of the vector A, okay, to the tail of the last vector C. Because they're just adding displacements, think of it like that. So the regular method of adding vectors using geometry. So this is the resultant now. This is the resultant vector R. Now we have to calculate this one's magnitude. Now you can see something special in the geometry of this, that if I now just extend this line, then I can break this quadrilateral into two triangles such that this triangle has equal sides. Okay, so that means this side has to be 2, okay, which means that this part here has to be 1, which also means that this part here is 1. So if you look at this smaller triangle now, okay, this is an isosceles triangle, and if you look at this larger triangle here, this was an equilateral triangle. Okay. So we can make use of that. So in that smaller isosceles triangle now, you can see that I'll just draw the smaller isosceles triangle separately. So that is something like this. This is the line that I got by extending. Okay. Then there is this side. It's a continuation of C, but this is also magnitude 1 because this side is 1. This is also magnitude 1, and this angle is 120 degrees because this angle is 60. And the third side of that isosceles triangle is the vector that we are looking for, which is R. So this same isosceles triangle, that's here. Okay. So now in this isosceles triangle, we can just drop this perpendicular that will bisect this side. So you can see that magnitude of R will become 2x. In that triangle, this angle is equal to this angle, it's 30 degrees. So x divided by 1, as this side is 1, is equal to cos 30 degrees. So x is root 3 by 2. So magnitude of r is becoming root 3. Okay. This is one thing we needed to calculate, and that we can do from this. Now secondly, we also needed to calculate this angle. We needed to calculate this angle, and that you can see very easily. It is 30 degrees plus 180 degrees. Okay. So instead of calculating that one, we will calculate, sorry, this one. That's the larger angle, so no need to calculate that. Calculate the smaller of the two. That will in fact become 180 minus 30. So this is the angle between the vectors E and the resultant. This resultant. So magnitude of the resultant and the angle both are calculated. Okay. So please make a note of this quickly. This is sixth and seventh question. After this, we will come to the 13th question. No, Bhavesh, 210 is not wrong, but when we say that the angle between two vectors is 210, it's the same as saying it's 150. And generally, as a convention, we always express the smaller angle. That is why we said the angle between two vectors is between 0 and 180. So technically, it's not wrong to say 210, but it's not the correct way. It's not the proper way of expressing the angle also. The proper way is the smaller of the two angles. Okay, so hope this question is clear to all of you. Let's come to question number 13 next. So question 13 is like this. It's saying that at t equal to 0, a particle is located at, let's say, a point A, which they are given as 1 comma 0 comma 0. Okay. So let's say this point A is over here. Okay. Now it is moving at a constant velocity towards. So it is moving towards another point, let's say B, which is given by the coordinates 4 comma 4 comma 12. Okay. At constant velocity. So let's take that velocity vector as v. So let's say the point B is somewhere here. That's okay. So the line joining A and B, that is the direction in which the the particle is moving. Okay, so let's draw that line joining A and B like this. So this is the in general the direction in which that particle is moving. So if it's moving in this direction, then the velocity vector will also be drawn along this only. So particle का जो velocity होगा वो ऐसा होगा. It will be a vector like this. This will be the velocity. So given the magnitude of the velocity, that is the speed, is 65 meters per second. Now what we have to find is position of the particle. Find the position, let's say C, which has some coordinates x, y, z at t equal to 2 seconds. So remember the particle is starting from A at t equal to 0. So let's say after 2 seconds it reaches somewhere here. So we have to just find the coordinates of that. Okay. So I will tell you the method and you try this out. So what you do is magnitude of V that is given to us, okay, and direction of V is along AB, the line AB. Therefore, we can express velocity as 65 into n cap, okay, where n cap is the unit vector along the line AB. So like this. Use this as a hint, okay, and then displacement is velocity multiplied by time, because velocity is uniform. This, okay. So use this to find C, the coordinates of the points. So just try to apply the steps that I've given in this question and work it out from this. Okay, so hope you have figured this out. So see, the first thing we'll have to do is express the vector from A to B. Okay. A was the point 1 comma 0 comma 0. B was the point 4 4 12. So the vector AB will be 4 minus 1 I cap plus 4 minus 0 j cap plus 12 minus 0 k cap, or 3 I cap plus 4 j cap plus 12 k cap. And the magnitude of will become root of, okay, so that is, so therefore n cap, which is the unit vector along AB, so that is nothing but 3 I cap plus 4 j cap plus 12 k cap divided by its own magnitude, which is 13. Okay. So therefore my velocity vector, which was 65 meters per second along that direction AB, so that velocity vector becomes 65 into 3 I cap plus 4 j cap plus 12 k cap by 13. Okay. So 13 goes 5 times in 65, so 15 I cap plus 20 j cap plus 60 k cap in meters per second. This is now my velocity vector. So that is the first step done. Now once I've got my velocity vector, so therefore I know that the displacement in 0 to 2 seconds, that displacement is velocity multiplied by 2 seconds. So the displacement is, so we just written the velocity vector above, so we just pick that up and multiplied by 2. So this is 30 I cap plus 40 j cap plus 120 k cap. So this is the displacement from the point A to C, whose coordinates you want to find out. Okay. So therefore you can see that x minus 1 is 30. So the x coordinate of C is 31. Okay. Y minus 0 is 40. So the y coordinate of this one is 40. And similarly, z minus 0 is 120. So the z coordinate is 120. So these are the coordinates of the point C. So C becomes the point 31, comma 40, comma 120. That is the final answer. So a couple of steps involved in solving this. So just note it down from here onwards. Okay, so once you got the velocity vector, okay, from that next thing you calculate the displacement, and from the displacement you calculate finally the coordinates of the point C. Okay. So just make sure you understand this question fully, and this is question number uh, 13. After this we'll be doing 21. Okay. So if you finish writing this down, just go through question number 21. We'll discuss that next. Okay, people. So hope this question is fully clear. Now let us move on to question number 21 next. This was question number 13. If anybody has a doubt in question before, yeah, Bhargav, see, speed is magnitude of velocity. ठीक है? In by definition, in kinematic speed क्या होता है? वो velocity का magnitude होता है. Velocity is a vector और उसका magnitude को ही हम speed बोलते हैं. So that is the idea. This quantity as a vector is defined as velocity, and magnitude of the velocity, that is what we call speed. So speed is nothing but magnitude of velocity. Okay. So therefore, if velocity is uniform, okay, what does that mean? That the velocity vector has constant magnitude and direction. दोनों चीजें constant है. Neither the vector is changing direction nor is changing magnitude. So automatically, this statement implies that magnitude of velocity, which is speed, is constant. Okay. So if we say velocity is uniform, it means that the speed is constant. Okay, let's come to question 21. It is a standard type of question about projection. So we need to discuss about that in detail. So vector E is given to us as I cap plus 2j cap plus 2k cap. Okay. Whereas vector B is given to us as 2i cap plus j cap plus 2k cap. And we are asked to find the projection of vector B on vector E. Okay. So what does this mean? This basically means that if, let's say, these are our vectors A and B, some kind of angle theta between them, then when we drop a perpendicular from B's head onto A's direction, then the component that this cuts, this is nothing but the projection of B on A. This one. This is okay. So the component or projection of B parallel to A. That is this. Okay. So that, as you can see, is B cos theta A cap, where we use the definition that B cos theta is A dot B divided by magnitude of A, and A cap is vector A divided by its own magnitude. Okay. So what you do is you find these, okay, and then after finding these, substitute them here. So you will be able to find this. Okay. And this is what has been asked in the question. This is nothing but this. So now just use the method which we discussed in class, okay, and work the steps out in between. Any more doubts in exercise 1, please send me. Otherwise, we'll move on to exercise 2 after this. Okay, people. So hope you worked out this question. Let's quickly do the calculation part. So pretty simple, really. Nothing difficult. So given these two vectors A and B, we need to first of all we need to find out B cos theta, which is A dot B divided by mod A. So A dot B you can see here is 1 into 2, that's 2 plus 2 into 1, so that's again 2 plus 2 into 2, so that's 4. So that's 2 plus 2, 4 plus 4, 8. Okay. And magnitude of B is, sorry, magnitude of A is nothing but root of 1 square plus 2 square plus 2 square. So that's 3. Okay. So this is becoming 8 by 3. That's the first thing. Okay. And then we need to find out A cap. So A cap is the vector A divided by its magnitude. So the vector A was I plus 2j plus 2k divided by 3. So now once we got these two, you can see that our vector, the component of B along A is nothing but the product of these two things, B cos theta into A cap. So B cos theta was 8 by 3 and E cap is I cap plus 2j cap plus 2k cap divided by 3. So this will become 8 by 9 I cap plus 16 by 9 j cap plus 16 by 9 k cap. However we choose to express it, and write this as this also, express it this way also. So anyway, this is the complete working of this. So finish writing this down if, in case you haven't worked it out yourself. This is question number 21 of exercise 1. And now if you have any doubts in exercise 2, please let me know. Let's cover the doubts of exercise 2 first. Okay, question number 7, we'll come to that. Okay. Question 2, we will discuss that also. Alright, so let's start with question number 2 of exercise 2. Okay, so the question is given us two vectors A and B. Now in this, see, there is no one thing the question is asking. Each option is basically asking you to check something else. So we have to solve this question option by option. Okay? So first option is saying that a unit vector perpendicular to A is given by the relation minus j cap plus k cap by root 2. So we have to find out if this statement is correct or not. Okay, so to find out this statement, we need to do two things. First, we need to check if it is a unit vector. Okay. So for that, we need to check the magnitude of this thing. So what is the magnitude of this? It is square root of 1 by root 2 whole square. So that is 1. So that we now know that, okay, the answer to this is yes. It is a unit vector. Okay. And secondly, we also need to check if it is perpendicular to vector E. So how do we check that? Dot product with E should be 0. Okay. So the dot product of this given vector with A is how much? We need to check that. Okay. So that is minus 1 by root 2 plus 1 by root 2. So that is 0. So that is saying that yes, it is also correct. So both the statements are correct. So therefore, statement A is true. Okay. Now in a very similar manner, you need to check the other options also. But I mean, not all of them are just checking the exactly the same thing. So we will see there are slightly different statements also. First, just note down this part, then we'll come to the second one. So for example, statement B, it is saying that a unit vector parallel to A is given by this. We need to check this. Okay. So now this one is much easier. Here, what we can do is a unit vector parallel to the vector A is nothing but A's own unit vector, which is vector A divided by its own mod. Okay. So that is nothing but 2 I cap plus j cap plus k cap divided by its own mod. So that is, so this is a cap, that is the unit vector along the vector E, and that is this only. So yes, that's true. So therefore, statement B is also correct. Okay. So now just use the same method here to check statement C and D also, and you will get this quite easily. So just finish off this question and then move on to question number 7 after this. Okay, we'll discuss. So you'll find use the same method exactly to check option C and D also, and you'll find it quite easy. Okay, so hope you got part C and D also from this. So similarly, in part C, you can see that it's given to you that the unit vector perpendicular to B is given by, again the same thing, minus j cap plus k cap by root 2. So first of all, you can see that mod of this is 1. So it is a unit vector. So that part is correct, that it's a unit vector. And secondly, dot product with the vector B. Remember, B was I cap plus j cap plus k cap. So the dot product of this vector with B is 0 minus 1 by root 2 plus 1 by root 2. So that is equal to 0. So it is also perpendicular. So statement C is true again. Okay. But if you look at the statement D, that one is not true because D is given to us that a unit vector parallel to A is this. But you can see that, but A cap was a different vector now. It was, so therefore this is not this. Okay, this is not the case. Okay. So statement D is not true. This was true. So that is question number 2. Now let's move on to question number 7 after this. Okay, so seventh question. Hope all of you understood the question properly by now. So it says that in a situation may be described by using different set of coordinate axes having different orientations. Which of the following do not depend on the orientation of the axis? So let me explain what the question is trying to say. Saying that I have the same situation, but I'm using two different coordinate axes whose orientations are different. So suppose my first system of axes is this one. I've described the given situation using this. So this is my system of axes. Okay, one less. And then for whatever reason, I'm also using a second system of axes, or maybe some second observer other than me is using a different set of coordinate axes. So they are using an axis which has a different orientation. So let's say their x coordinate, x axis and y axis are like this. So this is still perpendicular to each other, but this is the x prime and y prime axis, where this angle suppose is alpha, so this angle is also alpha. So my second system of axis is oriented at a different angle compared to the first one. Now I'm describing certain situation using this. So for example, if I have a vector, which is a vector A like this, and it has a magnitude of capital A. Now suppose that vector A is making some angle theta with respect to this axis. So if this is the case, so you can see that magnitude of the vector A is capital A in both systems. The direction of vector A is same in both systems. Okay, but in the same diagram, you will also understand that in the first system, components of vector A are A cos theta and A sin theta, whereas in the second system, the components of vector A are, let's say, Ax prime, which is A cos of this angle theta minus alpha, because in the second this angle is theta minus alpha. So you can see that in conclusion, Ax is not the same as Ax prime, Ay is not the same as Ay prime. Therefore, components are affected by the coordinate system used. Okay. But magnitude of the vector and direction of the vector, they are not affected. Okay. And similarly, a scalar quantity will also not be affected because scalar has nothing to do with direction. So hope this question is clear to you, Bhargav. Is the question clear? Okay. Anything else in exercise 2? Question 8 and 9 are done, I spoke. Pretty simple. What about exercise 3? Any doubt in exercise 3? I think they're pretty simple, exercise 3 also. So let's come to exercise 4 after this. If there are any doubts in exercise 4, please let me know. We'll discuss. We still have time for maybe a couple of doubts. नहीं भार्गव, it doesn't mean inclination remains the same. It means see जो vector arrow का direction है ना, वो तो absolute है ना. Now suppose see this vector A is pointing towards northeast. Suppose then whether I take my x-axis along east direction or I take my x-axis along west direction or whatever I do, but उसका direction तो northeast ही होगा ना. Suppose my vector E is pointing towards northeast. Okay. So now one guy has taken his x-axis along east. Okay. Another guy has suppose taken his x-axis at some angle like this. Suppose he is taken at 20 degrees north of east. But this does not affect the direction of the vector A. No? The vector A is still pointing in which direction? It's pointing towards northeast. So the direction of the vector doesn't change. The inclination with the coordinate frame changes. So accordingly the components change. But that doesn't affect the vector arrow. Vector arrow जिधर भी point कर रहा था पहले से अभी भी वही point कर रहा है. That is the meaning of saying that the direction is independent of that. Okay, so I'm guessing maybe many of you have not attempted the exercise 4 questions yet. So please do so in this week because next week we'll be starting with this thing, Newton's laws of motion. So before we conclude, just few things I want to tell about the next chapter we'll be studying. So next week we will be starting with the chapter Newton's laws of motion. Okay, all of you are familiar with the statements and all that, but for this we will be using reference books from now on. In addition to my notes and exercises which I'll be sending. So first of all, we'll be using the the iit submodule. Okay. Then we will also be using a book, Concepts of Physics, Part 1 by Dr. H.C. Verma. So we will be using this book also now on for both questions and theory reading. Okay. So please get hold of a copy of this book, and for next week, read the chapter Forces. I think Forces is it is chapter number 3, if I'm not mistaken. So it's a very short chapter, and it just gives an introduction to Newton's laws of motion before the actual chapter. It's actually chapter 4. This is chapter 4 in HC1. Okay. Read this chapter. Okay. So this is like a introduction to Newton's laws of motion. So it will help you understand Newton's laws of motion better when we come directly to that chapter. So please do this if possible before next week, and also complete anything pending in vectors. So worksheet, exercise 4 from your module, or even exercise 1 or 2, even if something is pending, in spite of us discussing the doubts today. If you've not attempted some of the questions, then please complete attempting those, because after next week, we will not get a chance again to discuss those things because we'll be moving ahead. Okay? So that's it for today's session, people. Wish you all the best.